Sample problem number 2. What volume of 0.250 moles per liter sulfuric acid, right, is needed to react completely with 37.2 milliliters of 0.650 moles per liter potassium hydroxide? Right? So, first step, and I give you guys the equation. Right? So we've got our acid, sulfuric acid. We've got potassium hydroxide as our base. So we're going to combine the two to form our ionic compound, our salt, and our water. Right? And just to save you guys the time from having to balance it, because remember, you always have to balance, because we want to find out ultimately the mole ratio between what we've been given and what we need to find. All right? So take a moment and work on this problem. Looking at our question, and we've got, we're trying to find the volume of the sulfuric acid. Right? But of the information that we're given, right, we're given the volume and the concentration of the potassium hydroxide. Using that, what can we find? The number of moles. Right? So first we want to convert the milliliters here to liters, so 0.0372 liters. So we've got our the number of moles of potassium hydroxide is equal to the concentration, right? We've got the pyramid C, N, V, right? We want to try to find the N, so we cover up the N, and we have C next to the V, meaning we're multiplying concentration with volume. So we've got 0.650 moles per liter times, right, our volume, 0.0372 liters. Right? Liters cancel out, and I'm left with 0.02418 moles of potassium hydroxide. So hopefully that's what you guys got. Now, that's what we have here. So we've got, let me just put it in here, we've got 0.02418 moles of potassium hydroxide. So what I want is to find the number of moles of sulfuric acid that are reacting with, right? And using that little table that we've created back when we went through the stoichiometry introduction, right? We're trying to find the number of moles of sulfuric acid, but we're given the number of moles of potassium hydroxide. So we have moles, right, and molecules, right? And we all know we don't really refer to them as molecules, but we're going old-fashioned, right? So potassium hydroxide we just calculated 0.02418 moles. The number of moles of sulfuric acid is what we're trying to find. But the ratio is a 1-to-2 ratio, right? 1-to-2. So separating these two sides, right, we get X over 0.02418 moles equals 1/2. So we want to isolate for X. We're going to bring the 0.02418 moles over to the other side, and we get X is equal to 1 times 0.02418 moles divided by 2, right? Because now, as a shortcut, because it is a 1-to-2 ratio, right? You want to reduce it to 1 mole, right? So how do you reduce 2 moles to 1 mole? Divided by 2, which means whatever that mole was, we're dividing that by 2, right? Because the 1 doesn't really make any difference to the numerator parts, right? So we get the number of moles as 0.01209, right? And those number of moles are for the sulfuric acid. Right? So that's what you should have gotten for the number of moles of sulfuric acid. Now, we've got the number of moles of sulfuric acid. We've got the concentration of the sulfuric acid, right? We have the C, we have the N. What are we trying to find now? The volume, right? So the volume is equal to the number of moles over the concentration. So the number of moles is what we just found here. 0.01209 moles divided by the concentration, which is 0.250 moles per liter. Moles cancel out. My answer will be in liters. And I get 0.04836 liters. But what are the least number of significant digits in my question? 3, right? So I want the 4, the 8, and the 3. So what does that become? What's my answer? 0. No. 484 liters, right? I take the 4, the 8, the 3, but I look at the 6. But now, if we were trying to work on this in the lab, right, we wanted to try to find the volume that we needed, would I keep my answer that way? No. I'd want to change it to milliliters. And in milliliters, my answer is 48.4 milliliters. Either or I would accept. Right? Either answer I will accept on a test. Okay. But if we were working in the lab, we do want to convert to milliliters because we will have graduated cylinders that will give us measurements in milliliters.